So our next speaker will be S Inselmann. Most of you will know him as well, of course. He's the global project curator at Sea Life, responsible for new projects, enclosure specifications, life support systems, and aquarium specifications. And his talk will be about ozone, safe installations and operations, the Sea Life way. Please, Stefan.
Thanks, Sam. Hello, everybody, and thanks for the opportunity, my annual opportunity, to put you all to sleep again. Thank you very much for that. Right. I will talk a little bit about my favorite subject, which is ozone. Ozone in aquaria, safe installations and applications. And I have to say right in the beginning, I'm not neutrally opinionated on ozone, using the phrase from Paul. I'm very much opinionated about ozone. I love it because of all its benefits it does to the water quality and finally to the fish health. But the whole talk is not about that, because I think we don't have to talk about this. We all know the effects of ozone, which can be seen in all our aquaria, and I wouldn't run systems, most of the systems, not without ozone, because the benefits are just so huge that I don't want to miss it. And I promise you also, these are the last nice pictures you've seen in my presentation. Yeah, the reason for this presentation is rather the reality I found around the world. I was traveling quite a lot over the last 2 years into different continents, different countries, and I was visiting a lot of aquaria, our own aquaria as well as other aquaria, and what I found there was sometimes, I have to say that quite bluntly, was very dangerous and scary. And just to show you some examples, this is an ozonizer, believe it or not. This is a 100-gram ozonizer, which looks very much self-made. I've never seen anything like that. Hip hip hooray, some aquaria have ozone gas meters, which is very good, but it does matter where you place it. And if you place one ozone gas meter in an inappropriate location, right in the middle of a plant room as big as a football field, right next to 2 fibrock pumps with a just localized audible alarm, you can't hear anything. It's completely pointless. And even more so, this wasn't even working. It was off. And it was an aquarium with an ozone capacity of 1.2 kilogram per hour without any controls and any alarms. Or some people, for some very good reason, because they love to clean the foam beakers, have simply cut openings into the foam lids for easier access. They could simply open this little lid, could brush the foam beaker, and found it very clever, because they had a easy to look after foam fractionator, but they just ignored the risk they were applying to themselves and risking their lives. In some places you find really nice ozonizers, but with a little bit inadequate labeling, for example. Some places do have personal protective equipment, but maybe not just the right thing. Other places, this is very hard to see, try to hit it. You see here a stainless steel pipe. This is the ozone pipe on a pressurized system of about 800 grams per hour, and that was the quality of the insulation across this attraction there. And all these pipes were very loose and fragile, and you just needed to fall against it, and they were just breaking and would contaminate the room just with ozone. ORP meters, yes, excellent, but in a completely pointless position, one ORP probe on the return pipe from a big 11 million liter ocean tank, and that was showing a signal of 472 millivolts on a return from a tank, and you would think, wouldn't the fish be dead with that signal? So that was never cleaned, never maintained, never replaced, never thought of. Or ozone dosage was just being done by hand, but good guess. A little bit more, doesn't smell, a little bit more. Right, and just to finish off this little introduction, setting the scenes, I would like to tell you a little bit about our standards in the company, which we've developed over the years. And Merlin Entertainments, it's the mother company of Sea Life, our prime commandments are the well-being of guests and staff, and the well-being of animals in custody, and then anything else. But these are the prime commandments in our company, because we're very much committed to the health and safety of visitors, guests, and the animals, of course. But if you follow, or if you want to design a life support system with an ozone system, and you look into the books and into the literature and regulations, you will quickly find out that there worldwide are very, very few good regulations you can follow. One of those is the UK ozone regulation, ozone health hazards and precautionary measurements. And I have to say, it's not a bad one, but it's also not a good one. Because it looks very good in the first place. It's a 40 page document. But on the second reading, you find out that it's a lot of should, would, might, could, and it leaves many things open for you to decide what you're going to do, and it leaves a big risk, in my opinion, to us as an operator. There's another one, which is the Richtlinien für die Verwendung von Ozon zur Wasseraufbereitung. That's the German ozone regulation, and that is very Germanic. This is like a law. Not much text, only 15 pages or so. It must be like this, must be like that. If it's larger than this, then you need to do this, that. Very Germanic, but very easy to follow. And these are, according to my very best knowledge, the strictest ozone rules in the world, and therefore Merlin Entertainment, and that has got a historical background as well, as we've built over the last 10 years 9 sea life centers in Germany, and we had to follow these ozone regulations, of course, in Germany, but we have simply applied these regulations later on in other European projects, and we are now applying it worldwide. Because that is just easy to follow, and you know you're always on the safe side if you follow those. These regulations have gone into the Merlin Standard Ozone System, the standard project, LSS project brief, and any contractor has to follow that worldwide. By the way, and I've not shown a picture of that regulation here, because I got hold of that only last week. A colleague from the UK supplied me with a document from British Columbia in Canada, and that is actually the best ozone document I've ever seen in my life. It's as strict as the German one, but it gives a lot more detailed background information and explains a lot, and it's just a pleasure to read if you're technical minded, but it's very nice. So, what are the Merlin ozone design criteria? And we have decided, following the German regulations, that any ozone system larger than 2 grams needs to meet the following requirements. It must be a vacuum system, no doubt about. We're not fussing about with it. We don't want to have pressurized systems because they have some operational benefits, yes, I agree. They're cheaper to build, but they're not as safe as a vacuum system. End of. It must have an auto shutdown of the ozone generator when there's no vacuum. So you can even, I could demonstrate it to you tonight when we do the guided tour, I could cut the ozone pipe and the generator would switch off in a second. Bang, no risk any longer. There must be an ozone gas monitoring system with an auto shutdown of the generator when the ozone concentration in the workplace, in the environment reaches the so-called MAK concentration, forgot the English abbreviation, OEL concentration or whatever, of 0.1 parts per million ozone. And it has to send out an alarm at any time. Of course, there needs to be an emergency off button outside the room where the ozone generator is located to make sure that if the auto shutdown, for whatever reason, doesn't happen, you have the chance to switch off the ozone generator from outside without going into the room. And then we need to have full-face gas masks for each staff member to be able to enter the plant room or the ozone room without any risk for anybody. Just a question to all of you. Why would you go into an ozone room? When would you go into an ozone room with a full face gas mask if this room is fully contaminated with ozone? Why would you go in there? No idea? I would never go in there because I would just switch it off and wait for the ventilation to get rid of the ozone. But there's only one reason why I would go in. And that is, for example, when I know there's one colleague inside and I have to rescue this person. That's the only reason why we have the full face gas mask. Otherwise, I wouldn't go in and take the risk, even with the full face gas mask, to go in. And of course, following the regulations, the ozone room and the generators as well need to have proper signage, warning signs, etc., etc. And very importantly, there needs to be continuous in-house maintenance following the strict procedures, and there needs to be an annual service by a qualified contractor, not any plumber who can do it or thinks he can do it. And ozone dosage needs to be ORP probe controlled. That is very important for us as well. Intensive staff training is also very, very important. You can install the best installations you can have, but if your staff isn't able to work with it or understands the system and regards it as evil maybe and doesn't touch anything, you're lost. Right, let's go to the operational side, a safe application of ozone. So how can we dose ozone? There are different concepts. One concept I've seen quite often in the world is with closed eyes, braveness and feeling. There's no controls, it's just the operators which, as I said earlier, just adjust more or less ozone based on their experience, feelings and whatsoever. I can't recommend it. Another concept is the so-called applied ozone dose. That is a phrase which was introduced in 2002 in a very good paper by Andy Aiken and Mark Smith, which is a very good concept, but I would only use that concept in order to size the generator, but not to run it, because it doesn't react. This concept doesn't react to the reality, because you set it once, and if the situation in the water is changing, which happens over the day, before feeding, after feeding, etc., etc., this concept doesn't follow the requirements. There's no ozone dosage on demand. And as I said, it's very good as a basic calculation, but too inflexible. Other places use bromine as an indicator for applying more or less ozone. Of course, there's a time delay as well as with the former principle. If you test your water once in a day for bromides, and you think, okay, we need to have less ozone, you adjust it, but that is then applied for 24 hours until you do the next test in the next morning, which is not good enough. And what I find very scary is that you actually test the ozone dosage on a factor which you don't want to see at all. You test on the poison you don't want to produce. And the best concept, in my opinion, is to apply ozone controlled by redox potential, or rather the ORP. The benefits are, it's online, it's reacting immediately to the demand, there's no time delay, and it's relatively accurate. You have to have in mind that an ORP probe is not like a voltmeter, which tells you exactly what the voltage is. It's something which is fairly accurate. You have to understand that, and of course you have to maintain ORP probes, to replace them regularly, but then you're fine. Another concept is to test on the total residual oxidants, the TROs, and this is, I would say, similarly to the bromide testing concept, not as good to really control the ozone dosage, but you can definitely double check your ORP because it's directly correlated. So what we do in sea life is a general rule, as much as necessary, but as little as possible. And the maximum ORP we are applying into any fish tank is 330 millivolts, because that's what you see in coral reefs in very clean water. That's nature, that's what we want to simulate. We will have an alarm set at 350 millivolts, which means that if the alarm in the tank is reaching 350 millivolts, there's something wrong with the system, and that demands somebody to come and to check the system potentially. And the maximum ORP at the outlet of a foam fractionator is set at 480 millivolts. We never go higher because we know that, as I said earlier, ORP and TROs are directly correlated, and beyond 500 millivolts, you're starting to produce bromides, and you start to produce a lot of TROs, which you don't want to see. And therefore, for safety reasons, we are always adjusting the ORP at the outlet of a foam fractionator no higher than 480 millivolts, allowing a little peak over, but never reaching 500 millivolts. And always, we're having two ORP probes in a system. One is after the foam fractionator, the other one is working as a policeman ORP probe directly in the fish tank, nowhere else, not in a mixing pipe or whatever. It must be directly in the tank, because that's the situation what you want to monitor. There's always a redundancy in that. And both probes have equal rights. If one of them is reaching the ORP concentration, the set point, it's switching off the ozone generator to make sure that we never overdose anything. All ORP probes have to be cleaned twice in a week to make sure that there's no bacterial layer growing on the probes, and to make sure that we have a very good signal. And we religiously replace ORP probes after 1 year maximum. There's no point in keeping an ORP probe, which costs not more than 60, 70 euros, for longer than a year. If you consider that your whole collection and the ozone dosage may rely on the accuracy of an ozone probe, what's the point to save that money? Why take that risk? And another thing is you should never calibrate a probe. You can do a lot of harm with it. I don't want to go into the details, but if I have a doubt that the probe is inaccurate, I throw it away and replace it. But nevertheless, the most important aspect in all this is staff training. As I said earlier, you can have the best system in the world. If you don't have the people to look after it and to operate it, you're lost. You need staff training, and that's why we spend a lot of time and money in order to train our staff and bring them up to speed with all the latest technology and understanding an ozone system. Right, and finally, I would like to send you a big Germanic thank you.
Are there any questions?
Set value. So do you think that's a big problem when these peaks go to 600 and 700?
Yeah, well, this is all about the fine-tuning and the adjusting of the ozone production capacity. I mean, I'm quite sure that you have a step switch on your ozonizer, so you can adjust it to the lowest possible level, and then you have, knowing your system a little bit, because I know the manufacturer, I think, quite well, there's another chance you can play with the ozone gas, the amount of ozone gas per hour. You can play quite a lot with it. When I adjust an ozone system, I'm standing at an ozone system for ages with my little watch and calculating checking the minutes, the ozonizers on and off, and always making sure that I'm not peaking over very much. If I'm peaking over very much, I'm reducing the amount of ozonized air a little bit, go further down, and to just adjust it. It's fine-tuning. It's really fine-tuning. But you're absolutely right. You should always make sure that you not just peak over. It's not just pressing 2 or 3 buttons, and then you think you're fine, and then it may really happen that it peaks over and is off after that for a long period of time, which you don't want to have either. Did it answer that?
Okay.
Okay, thank you.
Thank you, Stefan.